I'm hoping a few more people will turn up since they've added themselves to the agenda. But in the meantime, have either of you managed to play much with Grafast yet?
I have not tried it yet. Just read your blog post and looked at the code a bit, but not implemented it on my side yet.
Yep, fair enough. It's pretty new.
Yeah. Also very little bit more conceptual stuff. Kind of install a little bit of this. Nothing major yet. So I've actually got 2 projects I want to kind of switch to it now. So just waiting for the final, so to say, sign off and get ready and get cracking on them, kind of thing. So that'll be. I mean, they're mostly like POCs, so bear in mind that it's the kind of beta process for now. But I'm really trying to convince them to do it. So we'll see if it works. So
awesome. Okay, well, we may as well get started. Oh, hello. Hello, welcome.
Hello. Can you hear me well?
Yes.
Great. Hi, nice to meet you.
Nice to meet you. So we were expecting 8 of us. There's 6 so far. We give it another minute. Generally at the GraphQL working groups, about 5 past is when we start. That tends to be when everyone filters in.
Hello.
We may as well kick off with some introductions though. So first of all, everyone here has already agreed to the Grafast contribution agreement. The reason for that existing is because ultimately we'd like Grafast to become part of the GraphQL Foundation if they'll have us. So we need everyone to agree to the same or similar terms to the GraphQL Foundation itself, just to make that move, if we do move the project later, to be much easier, because we want this to be a very open project that everyone can implement. We'll do an introduction of the attendees, and just like at the GraphQL working groups, we'll do that in the order that people are listed on the agenda file. So I'm just going to paste the agenda file into the chat so that you can reference that. If you can call out the name of the next person, or that might help. Just moving my screen around. Hi, everyone. I'm Benji. I'm the person who invented Grafast, and I'm also involved quite a lot with the GraphQL working group. And yeah, I really care deeply about GraphQL and also about performance, hence Grafast. Gani's not here. Jem, would you like to introduce yourself?
I'm Jem, and I'm the other half of GraphQL. I tend to do all the bits that you don't see, rather than sat working on the code. We've been working on Grafast together though, but it tends to be Benji that then implements it. Next is Pascal.
So I'm Pascal. Hi, sorry for the slight delay, but I had to update Zoom. I'm working at the Hot Chocolate GraphQL server in .NET. I'm in the GraphQL ecosystem since a while now. And I've seen the talk at the GraphQL conf of Benji and showed my interest because what he showed there, or what you do, or what you folks do in Grafast, is more or less the same problems that we also run into. So we want to be close to the specification here, and we'll probably either early next year or even end of this year start building something like this into Hot Chocolate as well. So the next one would be Lars, which just joined.
Yeah, sorry, I was a bit delayed.
If you just want to say a couple of words about yourself, Lars, what you do and why you're interested in Grafast.
I'm interested in, normally I'm working as a cloud architect, mainly in focusing on optimizing DevOps and communications and so on. And I'm looking for something I'm new to work on. I have been looking on the sidelines with this system I was asked to join or suggested I could join, and that was the reason for it. I'm mainly backend and database developer before I started, and I'm a little bit annoyed about the way we have the APIs in the backend. So that's my interest in it coming from there. And sorry, I didn't hear all your other people's interests.
Ian.
So Ian, yes, I'm mostly kind of full stack developer, so done a variety of things. I think at a stage I swap between a lot of technology, like the typical every year you do a new framework, a new this, a new database, a new that, and I think like 4 or 5 years ago, so stumbled upon PostgreSQL because I had a very big issue with kind of a Mongo-based database and the whole N+1 problem, the traditional one, and it just caused endless headaches. And when I found PostgreSQL, I was like, hey, this is quite cool. And then since then, I just haven't let go, and I've just loved the idea around the way of putting business logic in SQL. So I've pretty much all my projects now are based. I mean, mostly for now is just still the version 4 PostgreSQL. But I think also just been following along as things have changed and the Grafast thing has come. So I've just been very interested in a bit of the future of what it is. And I think me particularly would be the whole way of kind of connecting to some, or the way version 5 connects to external data sources a little bit more streamlinedly. That's a bit of a fancy word to use. And I think similarly, might not know how to contribute, but I was just maybe interested to just follow along and just know where it's going, because it really has interested me, and it aligns a bit with how I do things and what I want to do, and I just love the whole stack kind of thing. So that should be me.
Great, I guess it's my turn. So hi, nice to meet you. I'm Theo. I was basically CTO in 2 different companies where I had a lot of challenges managing multiple services and connection together, and basically helping developer teams as well to transition to GraphQL and hopefully gain somewhat of performance, right? So I'm a huge fan of the ecosystem. I was not present that much in conferences, events, on videos, but basically I follow everything silently on my end. And when I saw that someone break through with that new approach, which was some of the ideas that I prototyped in Python a few years ago, I was, ooh, that sounds cool. I want to join the discussion and see how a spec is first written, right? And how I can collaborate and participate to that. That would be awesome, right? And so basically, I think now it's Matthew, which may have been a neighbor office a few years ago. Proton Smooth were on the same office, and happy to see you there.
All right, yes, so I'm Matthew. I'm not working on GraphQL anymore because I changed jobs 1.5 years ago, but I played with it quite a bit and with PostgreSQL before. And I've always wanted to try to implement one version in Rust as a pet project. Never started it, but when I saw that Grafast was happening and it was a spec that would allow to have multiple implementations, that's why I jumped on the wagon. So yeah, I'm here to watch what's happening, how it can help, and maybe try to get started with a new project. And that's it for me.
Awesome. Thank you, everyone. Really great context on why you're all interested in being involved in this. And yeah, it's worth mentioning that Grafast was not created in a vacuum. It's very much a case of looking at all the different solutions that were out there and then trying to build a system that could work for all of these different use cases in as easy a way as we can manage, which is why a lot of the focus has been on, for example, the plan resolvers themselves, making sure that they're the right shape for developers to actually write. Because of course, doing this kind of declarative programming when they're used to doing procedural programming is a bit of a shift. So we want to make it as painless as possible. I mean, it's something that people have already done when they've moved over to using React, for example, compared to maybe they were using jQuery or something else before. So it is a move that developers will make, but still, we should put a lot of effort into making it easy. Okay, so on the agenda today, we have two of the big issues that I see in Grafast before we're ready to turn it into a proper spec. So the state of Grafast at the moment is effectively it works. People are using it. It's already built into the post-GraphQL version 5 system. So I know that it works for like a very wide range of use cases within that system. But we still obviously need to test it for other use cases as well. But there are a few issues that have come out of that or weaknesses that I'd like to address before we get to the Grafast 1.0. So I put on the agenda global dependencies and early exit, which are two of the main things. Is there anything that anyone else would particularly like to discuss? Pascal, maybe you want to talk about how this might relate to hot chocolate, or I don't know if anyone else wants to add an item to the agenda. Otherwise, we'll just go with the agenda as is.
Yeah, again, we can have a like chat afterwards, after the agenda, if there's time. I mean, you know, there's nothing big implemented yet in hot chocolate, so not much to talk about.
Okay, awesome. In which case, I will share my screen. Just give me a moment whilst I rearrange my various windows. Okay, cool. Grafast status report. Okay, so we launched, as you've all seen, at the GraphQL conference on the 20th of September. Usage is increasing, but obviously still very, very early days. No one has reported any major show-stopping issues right now, which is fantastic. There are quite a few major things that I would like to change before we get to a version 1.0, before we create that spec. There's global dependencies, which we'll be discussing in a moment, and early exit. There's also partial planning. One of the weaknesses of Grafast at the moment is that it plans everything fully. So where there is polymorphism, it will go down each of the polymorphic branches, which then, again, if they have polymorphic branches, will be multiplied and again and again. So one idea is effectively to stop at each of those points and only plan as much as is needed. So if you only see cat and dog and you don't see like fish and ant, then you would only plan for those two different types. And the next time you run it, if you see a new type, you would plan it on demand, perhaps. So that kind of partial planning. And another thing that was discussed quite a lot at GraphQL Conf itself was the idea of exporting the plans. So building the plan up, doing all the optimization, calling all the plan resolvers, doing the deduplication, doing the optimization and the tree shaking, boiling it down to effectively what will happen, and then exporting that as maybe a JSON object that you could store into Redis or wherever you want. And that way, in future, you can then read that back out, repopulate that plan, and execute it directly without having to do the expensive planning phase again. So that is another thing I'd like to think about before we get to the spec stage. So let's have a look at global dependencies. If you've got a, let me turn on my little laser pointer thingy. There we go. So if you've got a GraphQL query, this is only a fragment of one, obviously, but let's say you're fetching your top posts and then you want the first 5 authors of each post. This might be like, you know, news articles or whatever with multiple authors. You might have a plan resolver that looks a bit like this. So you're given the post, since it's in a list here, and the first argument, and then you go off to your business logic, whatever that may be, and you give it the ID of the post that you want to get the authors for and the number of authors that you want to fetch. Now, at the moment, when we call a step, once we've done all the planning and it comes time for execution, we call the execute method on the step, and we tell it the number of dependencies it has, which in this case will be these 2 dependencies. So we call it with the number 2 here. And we give you the values for those dependencies. So for the post ID, it's going to be the list of the IDs, 1, 2, 6, 24, 127, 20, whatever those IDs may be. But for this first argument, this number 5 here, it's always the same number because it's a constant. But we have to give it the same length of list because everything in Grafast works in a similar way to how data loader works based on these batches, and everything in the batch has the same length. So what we do at the moment is we multiply up the constant. So when we go through top posts, the value 5 here would be a constant. There'd be 1 of them. Now we have 6 posts. So now we have 6 copies of the number 5, which isn't ideal because it means if we want to do this in, for example, a simple SQL query, we already know how to use the IDs here by putting them into a parameter. But we can't necessarily correlate each of these IDs with the limit that they should use. Really, we just want one limit that everything uses. And we can do that at the moment by just going through this list and making sure that every value is the same. But that's kind of a lot of like wasted effort. It seems like a lot of work for the developer to have to do. And also there's the cost of actually generating this array in the first place, like doing that duplication. It's not a lot of effort, but it's effort that we shouldn't need to do. So there's a few potential solutions that I've thought of for this. At the moment, we have this like add dependency method where you say, I'm going to need this thing at runtime, and we make sure that we pass you through the list of values that's related to that. One option is to add a special form of that, add a global dependency. And if you do that, then instead of getting a list, you'll just get the specific value. So that might go into your values array. If we were to do that, then things would get a little bit awkward, perhaps, because at the moment, anything that's in your values array is going to be a list, and all of those lists have the same length. If we make it so that whatever your global thing is also goes into here, then that's no longer the case, which makes things more challenging. That count there, that count 2 should actually be 6. I've made the wrong number there. Anywho, so that's something that you would need to track. Another option would be just treat all of our root level values. So any GraphQL variables, any inputs that are fed in directly through the GraphQL query text itself, like the first 5 here, for example, anything like the GraphQL context, any derivatives of those, like a derivative of the GraphQL context, like extracting a particular property from it, those could be made available like through the execute method, maybe via like a root values here. So it's always available. Either way, whichever of those we go with, and I'm honestly not sure which of those is better, one of the things that this will potentially rule out is cross-request batching. So at the moment, what happens in Grafast is we start with a batch size of 1 for your request, and we put in all of the context and the constants and things like that in that first batch. Then we run the first layer, and then if there's a list, we expand it up to the next layer and we bulk it out to the 20 items in your list or whatever, and so on as we go down through the layers. One of the optimizations that I was planning to do was make it so if you have, for example, 10 requests come in that are all calling the same operation, then they would all be able to, instead of having that initial batch size of 1, we could have an initial batch size of 10 and just do all of that work in a bigger batch. But if we were to do that, it's not necessarily guaranteed that this number 5 or an input variable actually would be the same value for each of those 10. So it would potentially interfere with that a little bit. But again, that's an optimization thing. I'm not sure if you have read the documentation in full or anything like that, or if I've lost any of you here. So if anyone has any questions on this or feedback, that would be ideal. Go on, Theo.
Yeah, quick question. When you speak about the spec, how does it relate to the actual implementation? Because I understand you're basically computing a direct data cyclic graph at the end of the day. How should the spec cover the way the graph is executed? I mean, maybe parallel step together on what the spec should allow user to make. I just wanted to get a bit more precision between the two.
Yeah, absolutely. So I suppose much like the GraphQL spec itself, in the GraphQL spec, there is a section, something like a resolve field value, that actually relates to calling the resolver. And we would have a similar thing in the Grafast specification that will talk about calling this execute method. So what is actually inside of execute, like what the actual code is in there, that's entirely down to whatever your steps are. But we're going to talk about these parts in particular, like how to pass the lists of values across. And that's why this is such a major, this would be a major change for what Grafast does currently, because at the moment, everything is just this tuple of lists. It's very straightforward, and adding this new type into that becomes more complicated, but it would definitely be that area of the spec that would deal with it. Does that answer your question, Theo? Fantastic. Okay, Pascal.
I haven't worked with Zoom in a while. I had to search how I raise my hand. I have 3 points and questions. So this add global depths basically would be used as the only for variables, because only these are basically global, because it's just in the query document. My question is a bit in the execute step. If I'm now in the execute step, how do I know what I have to get from root values and what is in this values array? You know what I mean? Like when I'm executing the step and I implement the step, how do I know where to look?
Yes, that is part of the problem, basically, yeah. So in the JavaScript or TypeScript implementation of Grafast at the moment, when you add a dependency, we give you back an index for that dependency. So because we pass this values tuple through, you know that the index in that tuple is the index of the dependency. So the first dependency you add will be index 0, the second dependency you add will be index 1, and so forth. So you are responsible for tracking which dependencies you added. So you know that the user IDs is going to be the first dependency, and the first value, for example, is going to be the second. And that's your job to track that as part of the metadata of your step. In TypeScript, that is just done however you like, but generally as a property on the class. But like, I don't think that the class or the instance of the class but like, I don't think that we actually need classes, and that's a whole different conversation. But this would be like, if you call add global dep, you would need to know either that I just read it from root values under this particular key that I'll give you, or that it will go into values if that's what we decide to do, and that the value there will no longer be a list as we would normally expect, but instead will just be the value directly. But that is something you need to track in your steps state. And the idea is that your step, because it's a step.execute, you will know what your steps built up state is.
Right. And the follow-up question is, why not, if this is anyway known in the step, so I have to know where to look, so I also know how to get this value, right? So you could also just give in a scalar value instead of an array, I guess. Or is this something else that then would lose? Like, you know, now you have this array that you have to blow up, but if you know that it's a global dependency, then you could also just be a single one. Or is there some hidden complexity that this does not work? That you
No, that's actually what I'm proposing here, is what we might do is just pass the scalar in. It just means that the simple thing that it's a tuple of lists is no longer true. Now it's a tuple of lists or scalars, and whether it's a scalar or a list is dependent on which method you use to add it in, and it sort of it's just a little bit more complex, and you know, complexity is to be avoided if possible, but embraced if necessary.
I see.
And just to clarify, you said that this global depths would only be for variables. It would be for variables. It would also be for constants like this, where they come in through the SDL, and also for things like the context, the GraphQL context, like who is the current user, that kind of things.
Yeah.
So there are a few use cases.
The variables is wrong. Argument values would have been more accurate, but yeah, the context.
Yes. So argument values and the context. Any globals, really. Matthew.
Yeah. I don't know if it makes sense, but could we pass, instead of a scalar, an object that acts like a list, but that we could also identify to be something else?
I did consider that. And the reason that I've ruled it out is because, or at least ruled it out for now, is because we want Grafast to be a spec, and specifying that list-like behavior in all of the different languages that exist that are maybe not as dynamic as JavaScript is might be problematic. I would certainly happily take advice on that. If we can see that that can easily be done in all the different languages, then that would be great. Another option similar to that perhaps is that values, instead of it being a tuple of lists, it becomes a tuple of like objects, where each object is either the list, it's either an object that contains the list or an object that contains a scalar, or potentially some other thing that we add in future. I'd also rather avoid that, just because it involves a lot more memory overhead and then garbage collection overhead if you have a garbage collected language. So, and also as Pascal says, like if you're tracking that you know what it is in advance anyway, we shouldn't need to give you that extra data at runtime, because you should already have it somewhere, or at least that is my hope.
Yeah, and if you didn't look at it, the constant value could also be a list, so it will be hard to distinguish if you don't know what to look for.
Yeah, it's definitely valid that the value of a variable can be a list. So just seeing if it's a list or not is not safe. Agreed. So my general sense from you, or I guess from Pascal primarily, is that just putting scalars into the values list is actually not that terrible an interface, so long as we make it clear to the user that this is a special thing, and if you use this, then you need to expect this different behavior. I had go on.
You know, I've also thought like in the beginning that you could also have some sort of access or delegate or whatever that you pass in, so that you know how to get it. You know, you get the values and whatever. But then I discarded, because if you think about it, this is executed so often that it actually really becomes necessary to avoid allocation. And even if you blow up this array to 5, that's also pretty much unnecessary allocation, because you need a big, depending on how much you batch, quite a big chunk of memory that you have to allocate and then throw away. So if you just have the tuple basically is this array of objects, and it could either be an array or a scalar, then the overhead would be minimal. You just have to, how you actually implement it in the end is up to you. But if the spec defines it as this is how it should be done, the value is just there, and you know how to fetch it, then I guess you have space for optimization.
Yeah, that makes sense. And you've hit the nail on the head with, this is such a hot path in the code that it is critical that we avoid any unnecessary allocations if we can. And it's the main reason that values is a tuple of lists rather than a list of tuples. If it was a list of tuples, we'd have to regenerate it for each step we execute. And that's a huge amount of allocation and then garbage collection. Whereas doing a tuple of lists, the lists already exist. They're already a thing we've got. So now we're just creating one single array to put those in, and a small one at that, and then getting rid of it again straight afterwards. So it's much cheaper. Okay, I feel more confident going with that scalar approach of putting the scalar into values than I was before. So thank you. This has been valuable. Did anyone want to say anything else before we move on to the next item?
Quickly, is there any reason you see we will not do that move? Because I mostly agree with all the reasoning, but is there like any performance that you implementation issue that you hit upon and made you decide to go with the array path instead of the scalar one?
No, it was just simplicity, and I didn't need it. Because primarily Grafast was built to power PostGraphQL originally, before it became a more powerful toolkit. PostGraphQL didn't have that need, so it didn't mind about the multiplication. And also, I just really liked the simplicity of that API. It's just a list. It's just a tuple of lists. It's very, very straightforward. It's very easy to understand. And I think broadly that will still be the same for most people, unless they choose to use this, which is effectively an optimization. And then they would be opting into this extra bit of complexity. There is a slight performance advantage of doing this one, the root values here. And that is that the root values will always, like, you create them once at the root, and then you could just pass that exact same object to every single step. You never have to reallocate anything. You never have to add anything to a tuple. So there is that value in that, but there is also a bit of a trade-off, and that is that you can't release any of that stuff. If it turns out that you don't actually need, like, once you've got past a certain phase, you don't need half of those values anymore, you would be able to release them, but not if we like pass this around as a single object kind of thing. So I think it's also probably clearer and cleaner to put it into values. Yeah, I think I'll experiment with adding it to values, and I'll see how it feels. But I think that does sound a more reasonable approach at the moment. As for the cross-request batching, I guess if and when we come to do that, anything that adds a global dependency would effectively opt out of that batching, and we just have to execute it once per request rather than once for all of them. But anything that doesn't use the global deps could still do a single batched a cross requests thing. Okay, go on.
Just before we move on, I have two questions. In the end, it doesn't really matter if it's in values or root values. If I haven't implemented it, so I can't really tell. But it's just that if it's in values, it kind of would make sense. So putting it in root values is also fine. I mean, these arrays could also be reused as I understand the planning step is synchronous, right? So you could just allocate the arrays once and then reuse them and just fill them and slice them how you wanted. A question though, you say, maybe I've missed it in the slide, but you talk about a fixed tuple of values. Why a tuple of values? Like 2, or depending on how many dependencies you have?
Yes, it'd be dependent on how many dependencies you have. It's an n tuple.
Okay, that's good. That's good. Then I think got it. It's basically an array of arrays, and you can reuse the arrays. Okay, makes sense.
Exactly that. Yeah.
Okay. About the cross-request batching, I mean, that's something. If you consider this is probably anyway Pandora's box, because we talk about when we now the cloud architecture, right? In the cloud, we're talking about the noisy neighbor problem, and now you have it on the instance with different requests and stuff like this. So that's going to be difficult. That has a lot of implication. It's really complicated, and it's really hard to secure the stuff when you have cross request batching happening.
Yeah, especially if anything like an unexpected error happens that then blows up 10 requests instead of 1, things like that. Yeah, for sure. And hopefully we'll handle as many of those edge cases as we can if we were to implement that feature. But I think it would definitely be opt-in. As you say, there is a lot of complexity involved in that.
Yeah. And one last question to this slide, and it's not on the slide, but you talked about that you execute in layers in the plan. Is this something because how the plan works? Because what we do in Hot Chocolate is we execute. We don't have this planning model. We do have execution steps and stuff, but we don't have the planning model of it. At least in the execution engine. In Fusion we have it, but in the execution engine we don't. So my question is, what we do at the moment is when you use data loader, we execute as far as you can, and then a data loader for us is basically an async step. So we execute all the leaves that we can until we are blocked, and then we batch, and then we resolve again until we are blocked, and then we batch again. That means that you do not really execute in layers. It could be that the user which is requested here in the tree and the user which is requested here in the tree further down of a different root node, for example, would be batched together. So it wouldn't be 2 requests. But I guess that's probably with execution plan planning, it's a bit different because each step is an async step, right?
Yeah, there's definitely a slightly different execution model in Grafast. So in GraphQL.js, for example, with just traditional resolvers, everything just races to complete as fast as it possibly can. So if you, for example, if it takes 10 seconds to fetch one of your users, but only like 0.1 milliseconds to fetch all of the others, then those will execute and all of their subfields will execute and all of those will execute. And finally, this one single slow user would do and then have all of their tree happen. Grafast doesn't work like that. Grafast does batching on a per step basis. So each of the steps will execute. We can execute a number of steps in parallel if they don't have any, if they're not dependent on each other. So they can all execute in parallel, and then we'll move on to executing the next level in parallel and so on and so forth. So there is no like splitting it up and doing half and half kind of thing.
Yeah, so that means the execution plans are structured a bit like the thing we do in Fusion, because you don't have these raising resolver problems. You basically have, you know what you fetch. I fetch this batch, and these are it's more than one field that you batch. It's not just one. Okay, makes sense. Thanks.
Yeah, I think it's very similar to what Fusion's dealing with. And I think there's a small trade-off there potentially with latency, but the idea is that because of the planning system, actually what you're doing is more efficient. So you are reducing latency by doing things more efficiently in the first place, which means that, yes, if you were to just take your resolvers and implement exactly them in Grafast, your latency might be higher. But if you actually use plan resolvers and start doing all the optimizations that Grafast enables, suddenly you get back that latency, and in fact you end up winning, is the hope anyway. Okay, moving on. So the next problem is early exit. And this is something that I wasn't particularly aware that we had as an issue until I started adding support for the relay node field, so the query.node field in the GraphQL object identification specification. So in that, you have a field on the query root called node, and you pass in a global object identifier, and the system decodes that object identifier, goes and fetches the relevant record, and then returns that to the user. Now, of course, that's a polymorphic thing for Grafast, so we now have to plan each of those possible things of what it could be, which is annoying. But in a lot of cases, we could know upfront, for example, this node ID that you've given us is invalid. So we want to be able to just say, no, just return null, just stop. And at the moment in Grafast, the only way to do that is to throw an error, because if there's an error, then we don't execute any further dependent steps on that. But we don't have it for anything other than error. And it turns out that actually just returning null is quite useful. And it's not just that either. It's also things like just returning an empty list. So for example, if a user, let's say a user hasn't completed registration, then we know that they've not got any friends yet because they've not been able to log in and add any. So we could just return an empty array without even having to go to the database or the data source and look. So I think we need something like this, but I'm not exactly sure what it will be. My first thought is, in your plan resolver, we could add something like an early exit if statement, which we pass in a condition and then some kind of value. So like this could be null, which just says exit with a null, or it could be an error, in which case it's, make this field be an error, or it could be an empty list, or it could be something else. I'm not entirely sure what that would be. Maybe this is actually going to be like an enum where it will only allow you to have certain values. Don't really know. There is also like a further question on this. Like, is this effectively a assertion that you have in your plan resolver that's kind of like an implicit thing that happens? Or is it a wrapper around a value? So effectively, if you get, let's say, the user's ID, and then we want to go and, I don't know, get their friends or something like that, we might wrap it with an early exit if the user's ID is null, let's say. And that way, when it comes to execute the child, we just go, oh, one of the dependencies has an early exit, so we're just going to stop here, and we're not going to execute these values from the batch for this child field. I don't think I've explained that particularly well. But yeah, there's some interesting complexities around that. So if this is something that sounds at least vaguely interesting, I'd love to go into more detail, maybe write some actual code with someone at some point. But I don't think there's enough time to do that on the end of this call today. Does anyone, again, this is all coming down to effectively the design of how the system works, like what the spec should say, when we were talking before about passing the values through into the execute step, in the happy case where no errors and no early exiting has happened, we've just got the lists that we already had, right? That were the output from previous steps just get fed into the next layer of steps, and everything's really great. But with this idea of the early exit, what we actually would need to do is filter the values down. So we would effectively know that, you know, items 2 and 7 aren't going to execute. So then we trim those out of the lists, build new lists that don't have those in, pass those through to execute, and then potentially inflate them back up again or do something like that. The inflating back up is what we actually do currently when errors occur. Pascal.
I just had to check on the documentation. There is at the moment no condition step, right?
Correct. There is no branching.
If or switch, because the question is, how do you work around this, right? In general, for this, you know, now for me the expertise in Grafast is missing to know how would I do a condition or how I work around it. I'm sure there's a way how to do it. So the question is, if you have a condition, because the early exit if error could also just be a condition. You could have if this, then exit, else do all of the other things. But I'm sure that you have a reason why there is no if and switch in it.
Yeah, we do. And that is that ifs and conditions like that make plans really complex, really big. They make planning a lot wider because now you have to do all this stuff on the left branch and all of this stuff on the right branch. So everything multiplies out. And it's one of those things that you think that you need everywhere, but actually you almost never need. So conditions yourself, you would probably actually implement via a step itself. So you would go and do your condition, find out what the value is, and then based on that, generally in GraphQL, and keep in mind that Grafast and like GraphQL resolvers are meant to be a very thin wrapper over your business logic. So typically it's a case of get the thing. If I have the thing, do the next thing. Otherwise, stop. There isn't really other than polymorphism, there isn't like a do two completely different things, because really this is a data access language. And you've said, I'm going to return a user. So at the end, you need to return a step that is a user. The question is, which user is it? Hopefully that makes some sense.
Yeah, I agree. I was sure that that's something that everyone says they need, but probably you don't. But for this, I probably need a bit more. I need to try it out a bit more, because I do have scenarios in mind where the early exit is something which I would definitely want to do. But I'm thinking about if it's only early exit that I want to do. You know what I mean? Like I know I have this early exit case. I have in probably most of the important business parts, but I have it in the service layer, not in the resolver. But for example, if you're not authenticated, then return null, you know, something like this. And here, I wonder if I always use it as the early exit, or if I have more complicated cases. Okay.
Yeah, and I would absolutely, like, that is one of the most valuable pieces of information. If you can find a case where early exit isn't sufficient to cover your use case, and it's a real world use case, not just something that you've like made up, then I absolutely really desperately want to know that, because I'm pretty sure that it's not going to be an issue for 99.99% of users. I think it's very unlikely that it'll be a problem. And as you say, when it comes to doing those kind of things in the business layer, like that's behind this execute. So you can do whatever logic you want inside of your execute. At the end, you're either returning a user or a null, you know, or you're returning, you know, a post or null, or an error. So you can do all the ifs and whatever that you want inside of that, but that doesn't mean that we necessarily need those things at the planning layer. Yeah.
There are a few interesting bits, because you may also want to not plan a certain thing. For example, it's just something which comes in mind. As you said, node resolver. I'm like, yeah, that's a problem. Because now you can basically, you have to plan for all the node types, always, even though in the real world, you always fetch only one node type. You know, if you write an application, you say, I have a refetchable query, and I want to refetch this user, it will always be a user. There's no need to plan anything else. You probably can infer this from the fragments, but you actually have to plan and whatnot. But yeah.
Yeah, absolutely. And that is one of the reasons that partial planning, I think, is also a big thing that we need. So what we can potentially do with those node IDs, for example, if we do that like root level understanding of derivatives, we can actually read the variable, let's say, and extract from that the ID, the identifier, extract from that what type it is. And then we would only have to plan that type. And then if a future ID comes in and it uses the same type, fantastic. We can just keep using the same thing. If it's a new type, then we would have to plan that next branch. But we shouldn't have to do that all up front. At the moment, we do that all up front, but we shouldn't have to. And that is something that definitely needs to be addressed before we make this a full specification and have lots of people implement it.
Yeah, I mean, yes. The problem is you plan anyway, right? Even if you don't specify the fragment, you plan anyway. If I have a node query and I spread in a user because I want to refetch the username of the user, and address is also node for whatever reason, then you also plan address even though the fragment is not spreaded into the...
Yeah, you would have to, because you need to know whether it's null or not. So if the value is going to be an address, you need to know how to fetch it so that you know whether it exists. But that's not exactly what I'm saying. What I'm saying is you don't need to plan the child selection set. So you don't need to plan executing the selection set for address. You just need to know whether the thing will be an address or not. And typically you can, in many cases, you can know that ahead of time, or you can know it at the right time. So for example, if you have a list of polymorphic things, a list of animals, let's say, that is not itself a polymorphic step. It's a step that returns a bunch of polymorphic objects. When you then get each of those objects, you can see which types they are. Oh, it's cat, dog, cat, 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 dog, fish, let's say. Now you know I need cat, dog, and fish to be planned, but I don't need parrot and budgie and hamster to be planned because I've not seen those. So I don't plan those selection sets. Mm-hmm. And then I can do that at a later stage if I need to.
I see.
So yeah, partial planning is another fun topic, and maybe we'll add that for next month's meeting.
Sure.
In the meantime, I think this has been really valuable. So my conclusions are, for the global dependencies, we'll just add it to values. We'll add a special method like a global dependency, and we'll add it to values. And for the early exit, I would love to get your feedback. I'd love you guys you folk, to think about what the different ways of using this might be, and find out if there are any exceptions where you actually do need some form of branching. Because there are potential solutions to branching, which we're currently calling sub-procedures, and they do exist in some weakened state at the moment, not particularly formal, but they are used in a couple of places. So we can do something like that, but I'm not convinced that they're needed for the vast majority of cases. So I'd love to know what cases they are needed for. So if you can all think about where you would need that branching at the planning level, that would be extremely valuable.
Yeah,
Is there... Go on.
I will check with check back with Fusion, talk about it with Michael, because we may have I know that we have conditions in it, but I need to check where we use them. So that's also on the planning level. So that's probably where things get interesting, right? Because as said, most of the things I come up with is stuff that's concerning the business logic. And this argumentation is really easy to do. You can just say, well, it shouldn't be there. It should be in the business logic. That's good, which is true. Don't get me wrong, which is true. But I will check where we use branching, because it could just be that we plan differently and we choose to do branching for whatever reason.
Yeah, because I know that, for example, you give multiple different ways of resolving something. Like it might go from this get a single item, or it might go to this get batch item in Fusion, and you choose between those, which I would guess is with some form of branching. But Grafast wouldn't do that with branching, like runtime branching, or even planning branching. What it would do is it would represent the concept of getting those things. And then when it comes to optimize, it would choose which of those it's actually going to do. So it works in a slightly different way. I think it can achieve the same goal, though.
And it's also that we don't have the problem that people have to implement the resolvers. We do it ourselves, which makes it easier, because then you can basically you decide how you plan. That makes it simpler. Don't have arbitrary complex resolver, because as soon as you have condition and switch cases, then things will explode, because then you have then whatever, just because you can. So it's easier that you just cannot do it at all.
That's why I very much would like to avoid adding it, and why I'd love to know if there's a reason that I have to.
There are two questions which arose a bit. One is like, do you have an ad hoc step, like where you can just pass in a delegate and do something?
There's a Lambda step, which you can just use to call an arbitrary function.
Right, true. I read that. True, that's good. And the other thing is, now when we talk about the business logic, I think with I've seen that there's a lot of SQL steps, right, where you go into Postgres and basically generate the queries. Which I see. The question is, in the .NET world, people really like to have these multiple tier services.
Yeah.
The business layer.
So those shouldn't be in the documentation. They are currently in the documentation, but what they should be is they should be in the post-GraphQL documentation. So just as a quick clarification there, for post-GraphQL, the database is the business logic layer. So when you are talking to the database, you're not just fetching data and then applying like logic on top of it. You're like, the database does all the logic. It has row level security policies. It has, triggers. It has functions. It has all this other stuff. So effectively, it's an access to your business logic layer. Though most people who don't build databases in that way and treat them as just a dumb store of data don't see it that way. That's fine. You have your repositories and so on and so forth, gateways and whatnot. But yeah, those specific plans like data plan PG shouldn't be in the Grafast documentation. It is currently, but it's going to move from there into the post-GraphQL ones, because I want to separate that completely from what Grafast is. anyone who implements Grafast would not be expected to implement data plan PG, data plan JSON, or any of the other like things. These are just bunches of step classes that might be useful. Like there could be a data plan Stripe, for example, for dealing with Stripe APIs, but that would never be part of the Grafast spec. It's just, you know, a library that someone's written.
The question there, it's pretty limited, right? I mean, you can directly connect it to the database. That's good. But for example, how much sense does it make that you have Stripe and whatever? Because as soon as you have Stripe, that's business logic, which means that you definitely need branching in some way. And it probably should not be, you know, for example, if this is user, then make an order where we have the if, and this is valid because if the user, for example, doesn't have an account in Stripe, then it cannot use the Stripe planning step. So it's a bit a question, you know. I do see the same. I do see the value of having the Postgres steps, because we do have a ton of users which just map their database through, also in .NET, and then extend it where they want with other resolvers. So I do see the value of having this planning capabilities on top of the database where you can optimize queries. I think the interesting piece is, and I'm really wondering how we figure out how we're going to do this. What's the best way of giving the context of what you actually have to do from the plan into the business logic without letting the business logic know that there's a GraphQL API in front of it, you know?
Yeah, absolutely. And I think one of the things that we encourage, but should encourage more, is you writing your own step classes. The step classes are how you talk to the business logic, and the business logic should not need to be changed at all to be supported. But if it wants to, for example, support a list of attributes that you should fetch, you know, instead of fetching asterisk, then it can do so, and then your steps can tell it to do that. If there is a thing, for example, if you're querying Stripe, you can know whether or not to include the additional resources. That doesn't have to be done with a generic Stripe class that maybe we would make as a useful thing for people. It might be something that you write yourself that relates to specifically your business logic. But that is one of the main reasons that we should be moving the data plan stuff out of the Grafast documentation, because I think it distracts from what Grafast is actually encouraging you to do, which is write step classes. Writing step classes for your business logic is the equivalent of writing data loaders for your business logic. So anywhere that you should write a data loader, you should write a step class.
Yeah, I've seen, I agree. That's exactly what I see. That's exactly what I see. I see that you have your business logic, it doesn't matter what happens behind it. But instead of now writing resolvers, you basically write these step classes or map them, maybe even automatically, depending on what it is. This is my function, create a step class, right? Whatever. And then you basically now write more of these in the middle step classes, and the resolvers then is basically, again, really simple. I mean, it shouldn't be, yeah. It makes sense.
That is it.
With I'm wondering how we do. We already have execution tasks and steps in Hot Chocolate. I need to see how we can wire them up into the planning thing, because we essentially return an execution task, not a value, which is a bit different of what we do. But I'm really interested in seeing how we can optimize the type. I mean, not the GraphQL type system, but the .NET type system of this. You know, that maybe we can. We auto-generate data loaders at the moment. Maybe we can do something similar with step classes. That would be really nice. For example,
interesting.
User. Now,
something to explore in another meeting. Theo, if I can ask you to be very quick, because we should end this and me and Jem need to head off.
Sure. Question was, you have like, what's the best place to get a look at all the step classes that you implemented for all the projects? Is it like in the PostgreSQL one, or it's in the Grafast repository?
So everything here should be in the Grafast repository, but here is a link to the step classes documentation, which talks about the main standard steps.
Okay, but that's everything that is available as of right now, because I've gone through that, but I would be more interested to see like concrete use case or example that you've wrote for PostgreSQL.
Yeah, there's not good examples at the moment. You would need to export like a post-GraphQL schema as executable code and then look through that, for example, which is a fair amount of work. And also that's not necessarily what most people should be doing, as we discussed anyway, because what your step classes do will be relevant for your business logic. I think there's one, like the friends and family or something like that example that we link out to from the documentation that's worth having a look at. I'll see if I can find it quickly.
And then the follow-up question is, I've seen that Azure is speaking a lot about data plane as well. Is there any connection with them or any common grounds?
I'm not particularly knowledgeable about that effort, but I don't think so. Here we go. It's called the users and friends example. It's just a really, really basic example. I think it uses SQLite or something like that.
Oh, perfect. Yeah, looks good so far.
Cool. All right. Thank you very much, everyone. And I'll set up another meeting for next month. If you'd like to discuss anything else, that would be great. And of course, reach out to me on Discord or file a discussion against the working group repository. Thank you very much.
Thank you. Yeah, have a good day.